So today is definitely an interactive lecture today. I have a whole bunch of SQL queries that I'm going to have you do because it's a lot easier to learn by doing, and these SQL the SQL language was designed to be learned by non-programmers, so I think the easiest way, as I said, to learn it is by doing. So both today and next Tuesday, I'll do a little bit of lecture, but then I have I've got a small database prepared for you all, and I'm going to have you do some queries on it. That also will make sure that you get a little bit comfortable with using your MySQL databases. Okay, so the basis, so the SQL query language, the book came up with 5 different distinctions. I think it called the SQL query language the data query language. I tend to call it the data manipulation language. So in my quizzes, just be clear that I view the query language as a data manipulation language. Okay, the book had slightly different terminology for it. It called it the query language. There are 3 fundamental operations in relational databases. They are called select, project, and join. Select filters out rows. Often you don't want to see the entire table. You just want to see some rows in the table. So you use a filter, the where command, in order to filter out only the rows you want. Project filters columns. So you normally, in the select statement, give the columns that you want to see. And then join, which we will cover on Tuesday, brings together or combines information from multiple files. So today, we're only going to be concerned with queries from a single table. On Tuesday, we'll go and look at queries from multiple tables that combine multiple tables. Okay, so there are 4 key commands. The one we're concerned with today is select. Insert, update, and delete are a lot simpler, have far less things with them, but do exactly what you think: add, modify, and remove data. Okay. Blah, 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 blah. I'm going to go over a few things that the book skipped over lightly. So you're used to things being case sensitive, but in SQL and in MySQL in particular, there's not a lot of case sensitivity. In our version of MySQL, the only thing that is case sensitive is relation names. If you, in a literal statement, if you say something like, select blah, 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 where city equals lowercase London. This isn't going well. There we go. London. And you use all lowercase. And in the database, it is spelled capital L-O-N. These will match, surprisingly enough. So you just got to get used to the fact that the only thing where it's case sensitive here at UT is with relation names. But when you get in the real world and you're using Oracle, then it becomes case sensitive for your literal character data, but that's just something to know. Another thing, the book skipped over and didn't really explain the difference between single quotes and double quotes. The book essentially said, well, string literals, you can put either single or double quotes around them. Well, kind of. If you want to be strictly compliant with what is the so-called ISO standard, which is the standard that defines SQL databases, you will put single quotes around your string literals. Double quotes are actually supposed to be reserved for relation and attribute names because you're not required. So column names and relation names are allowed to have white space. So technically, double quotes are reserved for relation names and column names. And single quotes are supposed to be used for string literals. The book wasn't clear on that. Now, our MySQL interpreter will accept double quotes for string literals, but I don't think that's universally true, and you shouldn't get in the habit of using double quotes for your string literals. Okay? I know I'm making a big deal about it, but that it is important. Okay. With that, as I said, I think it's pretty clear that when you're using select, here is the portion right here that is specifying the columns. If you want everything, you can use an asterisk. And then, second, come on. The where clause is where you filter stuff. And I think that's all pretty clear. So what I want you to do is practice it based on what you read in the book. So I have, if you log in, so log in to your computers and log into Hydra. Oh, by the way, the other thing, you may have wondered why I made you read section 15.5 and 15.6, which was the SQL workbench. The reason is some of you always want to do your stuff at home, and that's probably what you want to use if you're going to work at home. You probably want to load that onto your computers, and then you have a functioning SQL database on your computer and you don't need access to the web. But it's always fine to just log into the Hydra machines and use that instead. So if you don't plan to use SQL Workbench in this course, then forget about what you read in sections 15.5 through 15.6. I won't hold you responsible for it. But should you want to work on your home computer with it, that's what I recommend, is you download that and work with that. Okay? Okay. So log in, and I'd like you to log into your SQL databases, and I will do the same thing. If you don't have one with you, a computer, just follow along with your neighbor. And this is my database. If you try this, this won't work because you have to obviously use yours. So you'll come in, you should be at this prompt. Okay. I have prepared for you a file that we're going to take a look at quickly. So it's called createdb.sql, and it's going to create 3 tables for you. So the first table contains students, first name, last name, an ID, and a GPA. Second table is going to be a list of courses, course ID, course name, location. Third table is going to be called student courses, which is basically the roster for each course. So student, course they're taking, the grade in the course, and their weighted score. Then I have some insert statements that insert rows into your different tables. So Smiley Vanderzanden's ID is 1, and she has a GPA of 3.92. Minnie Mouse has ID 2, GPA of 3.5. Then here's some entries in the courses table. CS140, Intro to Data Structures, held in Claxton, because this is old data. We used to be in Claxton Hall. And here's some things. So student ID 1 took CS140, got an A- with a score of 89. Okay? So we're going to be doing some queries on this database, but the first thing I need you to do is I need you to load that thing into your compiler. The way you're going to do it is with the source statement. Okay, and I always forget whether I'm supposed to use parentheses or not. I think let me look at my SQL notes. That's why, my MySQL notes, that's why I have them. And the source command, nope, I don't. Okay, so we are going to use the source command. And that should be your thing. And if you hit return, it should set up your tables for you. Okay. Yes.
If you already have the code in your current directory, can you do source and then just name the SQL file? Or?
Yes. So if it was already, if you were in that directory, you could just say source create db.sql.
Okay, I copied it.
Okay. Yep. So that works. Okay. We there? You good? So if you type show tables, it will show you the tables that have been created. If you type describe and the name of a table, it will give you the schema for it. And if we'd like to look at one of them, select star from, notice I'm not capitalizing, student, gives you a nice table with the result. Okay, good so far? Okay, let's do some queries. So, first one, we've already done our inserts. So, let's print the course ID and the name from the courses table. So, print all tuples from the courses table, but all I want is the course ID and name. If you forget if you don't think these are the right attribute names, you can always type describe courses. By the way, you have to put a semicolon, and you'll see what the name of the attributes are. So I want you to print all tuples. I want the course ID and names of all courses from the courses table. You're looking at me with a funny expression. No, you got it? Okay. Course ID and name of the course. Oops. Okay, I think this one should be pretty easy. Select, and actually, take a look. So we're going to select course ID and course name from courses. That's the query. Okay, again, notice it's case insensitive, so I'm not worried about capitalizing anything. Questions? Pretty simple. Let's make it a little harder. Okay, print the first and last names of all students with GPAs greater than 3.5. So first and last names of all students with GPAs greater than 3.5. You may have to look into the book as the queries get harder, and feel free to work on it with a friend. We ready? Anyone need more time? Yes, no? We good? Okay. So, should be pretty easy. Select first name, last name from student where GPA greater than equal 3.5. Okay, simple enough. Now let's do it in sorted order on the GPA. So this time print out the GPA as well as a third field and do it in ascending order on the GPA. So I want it sorted. Right now, if I were to print it out with the GPA, it's not going to come out in sorted order. I want it in sorted order, ascending order. So figure out how to do that in sorted order. And once you figure it out, do it in descending order. What's the magic keyword? Order by. So if I add order by GPA, so sorting is done using order by. What if I want it in descending order? I never tried that. I don't think it's going to work. Cool. Well, that's not what I had in mind. Thanks. that is hacking. So that might work with numbers. That's not going to work so well when you get to last names. Cute. Less hackish.
It might still work if it's ASCII.
Pardon?
If the source print by the ASCII is for hash,
I don't bet it doesn't. Just a sec. I'm going to order it by last name. And then I'm going to do a minus next and see how it feels about that. Wow. Impressive. Okay. Well, we all know minus works. We learn something new every day. Anyone know the keyword that Brad is looking for on Jeopardy? DESC is what Brad is looking for. That will do the trick. Yes.
So you said case doesn't really matter, but like on the ZBooks, all of the keywords are in like all caps. Is that standard?
Yeah, standard. So when you're trying to make it look nice, you put all the keywords in capital letters. And that way, someone looking at it can quickly distinguish the keywords from column names and relation names.
Okay.
So, yep, that's totally standard. And you can have multiple things with your order by, you're allowed to have them be comma separated. So if there's a tie, like on mouse, I could have, so just sort it by last name, descending, and then I could have said first name, and that would have broken the ties. So now Jerry appeared above Minnie, right? Okay. Next one. So I want you to print all the courses that are in Claxton, but I don't think I did my data right. I wanted it to be like Claxton 103, Claxton 205. So pretend that Claxton isn't the full name. Okay, I know in the data, if you look at the data, so if I say select star from courses, I know that it says Claxton, so you could say equal Claxton. Pretend that the locations actually read Claxton 103, Claxton 205, Ferris 201. And I want all courses that are in Claxton. So you can't anymore say select from, something from courses where something equals Claxton. There's something else from the book I want you to use. Basically, you're looking for fragments here, right? Everyone clear on what I'm asking for? Okay. So all courses that are held in Claxton. If you want to test your code to make sure it works, I just updated the file. So if you redo the source command, I changed it so that courses, if you redo, what? Wait a minute. Do I not have a write command? Just a sec. What the heck is going on? Just a sec. Ah, it's changed in the wrong. Never mind. Gosh darn it. Changed on the wrong computer. Here. Keep working. Okay, I fixed it. Now if you resource it, you can check your code against it.
So does that mean we have to exit out?
No, you just type source again. If you use the arrow key, it will repeat. It's like a history command, so you can.
So then we should be able to do the sort by, right?
Yes. Okay. What's the key? Select star from courses where? Location like. The command I'm looking for is like. Then we use a string literal, Claxton. And what do we terminate it with? Percent sign. Because we can't use an asterisk like every other regular expression in the world. We have to use the percent sign. The percent sign is like an asterisk in the regular expression world. It means it matches 0 or more characters. If you just want to match one single character, would we use a dot like we would in the rest of the world? Why, no. We would use an underscore. So, if in this case, I'm using 4 underscores because there was 4 spaces after Claxton. So that meant underscore, a single underscore means matches any character. Percent sign matches 0 or more characters. So like is pretty restricted in terms of regular expressions. I saw the book said MySQL has a regex library. I didn't know that, so I need to look it up myself. Anyone have experience using the regex library? You do? So is it more like Python or PHP or?
Oh, I thought you were talking about Python.
Okay. No, I meant, okay.
Yeah,
At any rate, what's built in is pretty weak, but at any rate works kind of well. Okay, next one.
by the way, if you use the negative with this one, it doesn't work. Only descending works with ordering it.
Really?
Yeah.
So what do you mean here it doesn't?
I ordered by location,
Uh-huh.
the negative, and it didn't change it. But then when I used descending, it did.
Really? Select star from course.
Unless it just messed up.
Well, huh.
But if you do the descending, it does work.
Ah, I bet spaces is somehow having an effect. You're right. Interesting. Ha! That's right. Redemption. That's interesting. That's kind of interesting how that works. Okay, let's see. DDD. Okay, now what I want you to do, we're not going to do a join, so that's going to be too complicated. So what I want you to do is print, just a second, I have to look at the, so this is going to be student courses. So I want you to print the student ID and grade of all students who are taking either CS100 or CE206. So the student ID and grade of all students who are taking, and course ID, let's go with course ID too, of all students taking either CS100 or CE206. So I'll start it out for you because it's only the where clause that's interesting. It's the where clause that matters. CS1, it's right here.
Can you repeat that?
It's
number 11.
It's number 11. It's query 11. Except instead of names of GPAs of all students, it's we good? Okay, there's two different ways to do this. So the first way is to use their Boolean logic. So I could say CS100 or course ID equals CE206. So that's the verbose way of doing it. Did anyone come up with the simpler way to do it? Pardon? No, do not do this. So this is a common mistake. That didn't go so well, right? You only got CS100. So if you can't write it out like that, that will. So that's saying basically where course ID equals CS100 or true. In fact, I'm surprised you didn't get more out of that. Anyone else get? There's a slightly less verbose way. Okay, so the in keyword allows you to give a list of things. It's very helpful. Make in your friend because that way you don't have to write things out. So in, much better than having to write out a series of or statements. And just like that is very nice for or, something you should tuck away for, if I ask for all GPAs between 2.5 and 3.5, you could write that in two ways. Select star from students where GPA is greater than equal 2.5 and GPA is less than equal 3.5. Or you can use the between keyword. What? Yeah, that's because I really should have named that stupid relation students. I'm not as big a fan of between, and it's inclusive. So it includes anyone with 2.5 and 3.5. Remember, this was designed for non-computer programmers, hence some of the verbosity. Okay, that takes us through a quick tour of that. One thing, so again, I don't have anything that looks like it, so I'm going to have to go through, I'm going to have to go back to my slides for a moment. Okay, sometimes you want to be able to retrieve tuples where a column's value is null. Okay, so for example, I might want to get all viewings on properties where a comment was not supplied, i.e. where the comment is null. And you have to write it this way. You have to say where the column name is null. You can't say where comment equal null. That won't work. Okay? Got that? Don't say where comment equal null. Say where comment is null. I don't know why they made it that way, but they did. And if you say where comment equal null, it won't work right. It if you put
you put any regular operator like equal
Mhm.
or minus with null, then it becomes null by default.
Huh, okay. But why they still made that decision is beyond me. I understand what is happening. I don't know why they decided that had to be the case. So if you want all comment fields that aren't null, you would say is not. Okay. Now, we also like to be able to sometimes do aggregation. So there are 5 aggregation operators in SQL. Count returns the number of rows in the column. Sum, the sum. Average, I don't need to go through them. You should be able to get it. Okay, so if I do as an example, let's say I select count star from student. That gives me the number of tuples in students, which is the cardinality. I could select min GPA from student. That gives me the minimum GPA. I could select the average. Gives me an average. Okay. Now, we will get to this next time. This seems very reasonable, right? Select, so you might like to be able to do that, right? But perhaps we can't. That is very annoying. Okay, you also can't do this. Select last name. You might think this should return the first and last name of the person with the minimum GPA, right? Seems reasonable. Well, last name's not known. What did I call it? Oh, sorry. From. So it looks like Smiley has the lowest GPA, right? Except that's not Smiley's GPA. Bugs Bunny. Yeah, poor Bugs. But you know, Wile E. Coyote gets all the damage in Bugs Bunny, so for once Wile E. Coyote comes out on top. But the point is, it doesn't return what you would think it did. It returned the first line in the file. We will get next time or the time after into how you handle finding how you do this, because you can't actually put an aggregation operation into a comparison statement like that. Seems dumb, but you can't. Yes.
Is there a way to find the degree of the table, not the cardinality?
No. So the question was, can you find the degree of the table rather than the cardinality? And the answer is no. The reason is the degree refers to something in the structure, whereas cardinality refers to something that can be computed from the database, from the values. So it's slightly different. Okay, so you can get these values, but you can't actually necessarily find out who's associated with the max or the min. We will get to that. Count, min, and max apply to both numeric and non-numeric fields, but obviously sum and average to numeric fields only. The functions do eliminate nulls and operate only on the non-null values. Sometimes when you don't want to deal with duplicated values, you can say select distinct. So that doesn't come up a lot because normally if you're doing the average or the sum, you want all values, not just duplicated ones. But if for some reason you wanted to get rid of your duplicated values, you could say select distinct. Okay, the more interesting use of, okay, so this is saying what I read this statement right here. Okay, just take a moment to digest it. Okay, bottom line is if you use an aggregate function and you're not using the group by clause, that's all you're allowed to use. You can't have other attribute values. Now, oftentimes, here we go. This is where distinct could come into play. So you might want to have a query. How many different properties were viewed in May? So I can say, and this is, by the way, a cute use of between. So I am selecting, and I say count distinct property number as my count. So the as renames the column. From viewing, where the view date is between May 1st and May 31st. Now, the properties may have been viewed multiple times, which is why you want to use distinct here to eliminate the duplicate. So that's a good example of where you might want to use the distinct keyword. If I did not rename this as my count, instead of my count appearing in the solution, I would literally see the column named as count distinct property num. So the as allows you to give it a more nice name. Okay. Now, oftentimes what you want to do is you want to group stuff rather than doing it here. Let's say that I want to know, so I could say select, whoops. Count star from student courses. That gives me the number of tuples in student courses. Let's say, though, that what I want is I want to know how many students are enrolled in each of the courses. Okay, so if I look at oops. Thank you. And what am I? Wait a second, give me a moment. Yeah, it was capitalized. Okay. So what I want, I'm going to want the enrollment in each course. So what I'm trying to do is get all the records from CS102. Am I not? Okay. So for example, I'd like CS140 to say that I have an enrollment of 4. Okay. So what I can do is I can do something called the grouping operator. So what I'm going to do is say I want course ID count star as enrollment from student courses, and I'm going to group by course ID. And what that gives me is the number of students in each course. So the group by operator allows me to start aggregating tuples together by some criteria, in this case by course ID. Because oftentimes you want that aggregate information for a specific like course or branch. So you want to aggregate all the tuples with the same branch number or all the tuples with the same course ID. Okay, so let's do, or maybe notice that now I want to know what the average score is in this course. So count star as enrollment and average of score as average score. Again, from student courses, group by course ID. And now it gives me the average score in each course and the enrollment. Okay, now because I can notice that now I do have an attribute in the select list in addition to the aggregate operator. Now it's legitimate as long as that appeared in the group by clause. So any attribute that appears in the group by clause can now also appear up in the select, because that gives me the identification of what each group is. So I'm basically allowed to identify my groups. Okay? Any questions so far about grouping and aggregation?
So the group applies to all aggregations?
Yes. Well, you can do an aggregation on an entire table, but it's often not very meaningful. Right? You can ask for all the account of all the tuples in student courses, but that just gives you basically all the tuples. So normally you use the aggregation operators with group by, but it's not required. Okay, now let's say that I want to know about our problem courses, so where the students are struggling. So let's say I want to know about all courses where the average score is less than, say, 80. You might think that I can say where. You would be wrong. In this case, we are applying the filter condition to our groups. Where applies to individual rows, having applies to groups. So what I'm going to say is having an average score that is less than 80. And that prints out only those groups whose average score is less than 80. Notice I didn't have to say AVG score. I'd already renamed the column to average score. So I can use having to filter groups. Where filters individual tuples, having filters out groups. And you can put an aggregate operator in a having clause, but you cannot put an aggregate operation in a where clause. We good? Kind of understand what I just said? We can review that. Okay, so we use group by to get basically subtotals. We organize the tuples into subgroups, and then we're getting subtotals for those groups. So if a where is used with a group by, the where is applied first to eliminate any tuples we don't want, and then we group on the remaining tuples. And then we use having clauses to filter out groups. So having similar to where, but it filters groups rather than individual rows. And having filters based on aggregate functions. So it eliminates groups after the aggregate function is computed. Okay. So I got a couple, we'll end with y'all doing a couple queries with aggregates. So I showed you already how to print the enrollment in each course. Now I want you to print the enrollment in each course, only printing courses with an enrollment of 3 or greater. So print the enrollment in each course, but only courses that have an enrollment of 3 or greater. And I'll put up an example of my having a slide in case you need. That's too much help. Yeah, you're going to have to do it on your own. My only having slide essentially gives away the answer. So you have to look in the book. Ready? Okay. So we are going to select course ID, count star as enrollment. We don't care about the average score. Apparently I don't have, okay, we'll get rid of average score. So we want the enrollment. We group by course ID. Having count star or enrollment, it doesn't matter, greater than 3. Or did I say 3 or more? Doesn't matter, 3 or more, greater than or equal to 3. And there you go. And notice it's not ordered properly, so you can use the order by clause to order things then. One thing that sometimes gets people on the homework assignment is students notice that group by seems to sort. Notice how it's sorted by course ID. So group by does sort on the attribute, but if you need to sort in general, it should be order by. So for example, if I was really looking for enrollments and sorted order, I'd have to then add order by. So don't get suckered into thinking group by sorts. It doesn't really. If you really want to ensure that something gets sorted, use order by. But I see students on some homework, on the first homework assignments, sometimes using group by to force a sort. That doesn't really, it's not the purpose of group by. Okay, got another one for you. Now I want you to print out each student's ID and the minimum score that they received in any course they took. So what you're now trying to do is print out for each student ID the minimum score in any course they took. It's still going to be a query on student courses. You're going to print out the student ID. I don't care about the course ID because it turns out you can't get at that. I just want to know this, for each student, their student ID and their worst score in any course they took. Yes, so here, let me actually, I'll give you an example, okay? Easier to give an example. So here, for student ID 1, their worst score is 85. For 2, their worst score is 72. So what I want is, what I want you to do is print out the student ID, and for each student ID, the worst score. So for 1, it would be 85. For 2, it would be 72. For 3, it would be 46.
only time you need group by is when you're aggregating, right?
Yes, the only time you need group by is when you're aggregating.
So does like min, max, and count and whatnot, does it calculate all that in runtime, or is there like just local variables stored?
It does it at runtime.
Alright, so if there's like a million data points, it'd take a little bit.
Time to crunch through it, yeah. It would not necessarily be your fastest operation. Although these days, solid state memory and everything. Okay. So we will be selecting student ID and the minimum score from student courses. And we're going to group this time by student ID because we want for each student to basically have it group all of the students' courses together. And there you go. It gives the minimum score for each one. So in this case, the grouping was by student ID because you're grouping all the student records together. Does that make sense? That, okay. I have 15 minutes, so I'm going to show you something. So I did pose the question. So this isn't as useful as it might be, right? Because what you really would kind of like is to know what course they had that minimum score in, right? And we already said it's kind of like with, I wanted the minimum GPA, I couldn't get it. If I tried to do select first name, last name from student, where GPA equals min GPA, it says invalid use of the group function because I can't use the aggregation operation there. Okay, here, if I go back and I say select student ID, I can try to say course ID. Okay, and we can check now to see if this is right. Actually, I'd never done this before. So for student ID 1, let's select star from student courses. You can see it was wrong. Okay, it selected the first course ID. So it's not giving me the right answer. So clearly we would like to be able to answer queries like this. How do we do it? So I'm going to sneak ahead because I have a few minutes to actually a lecture that is a week from today called Subquery Slides, but it'll show you the answer. So a subquery lets you nest a see, I've nested one query inside of another query. So what I'm going to do if I want to get the minimum GPA is I have to nest the query for the minimum GPA down here. So what I'm going to do, I'll write it out so you can see it. I am going to select first name, last name, GPA from student, where GPA is equal. And now I'm going to use what's called a subquery. Select min GPA from student. So that's how it works. You can use what is called a subquery because, see, I'm using a select statement inside of a select statement. That's why it's called a subquery. And that select statement is returning a single number So it all works out well. So that is how you're able to do it, is with subqueries. Now, I am curious whether I can do that with that having, because I've never tried it before. This is always dangerous, to try to do it live. So, what we're going to try to do I'm not going to try to do it live. I will figure out how to do, I'm not quite sure how to do it where I'm doing the aggregation, but I'm sure there's a way. I just have to figure it out. So I'll try to figure that out for next time. Before I let you go, that's kind of complicated. SQL also has, I think, variables. So the other way that you could have done it is you're allowed to name a variable using the @ sign. So select average salary, equals average salary from staff. So that assigns a scalar value to the variable. Then, having defined that variable, you're allowed to use it in queries. So here, I'm trying to print out all staff whose salary exceeds the average salary. So I first compute the average salary, then I print out the difference between the salary and the average salary, where the salary is greater than average salary. So you can declare these SQL variables, but they're only allowed to store scalar values. They can't store tables. Is there a way to print those variables? Not that I know. Just a second, there might be. Let me try the select statement. So let's say select average salary equals average, well, that's not going to work. Let's say average GPA equals average GPA from student. Now let's say select average GPA. Ha! Worked. Okay. Okay. Questions about anything? You should be able now to tackle most of homework 1. I'm not sure. I think homework 1 also includes some joins, so you probably have to wait until Tuesday for the rest of it. But you can definitely get started on it at this point. Okay? The other thing, someone came up after the end of class on Tuesday. The dates I used are out of date for the homework, but if you change all the August dates to January and all the September dates to, so if you do a global search and replace of 8 with 1 and 9 with 2 and 2018 with 2019, it all works. I plan to do that too, but,
I think it's 2020, not 2019.
oh, 2020, thank you, 20, yeah. So I'm going to do that too, but just that's very fast and it should make everything work. Okay, yes.
Is there anything else you wanted us to change besides the dates?